You have 70 days till your SAT. It's time to learn some math. Level 1, we have 7 pounds of plums, make 8 rolls of fruit leather. If every batch of fruit leather requires the same amount of plums, how many pounds of plums are required to make 20 rolls of fruit leather? Okay, all this today is about rates and proportions. Proportions means fractions, so we're going to just set up our fractions. So they tell us 7 pounds of plums makes 8 rolls of fruit leather. And they want us to find out how many pounds of plums is required to make 20 rolls of fruit leather. So if we set up our two fractions so that they're equal to each other, we've set up our proportion. So I put both the rolls on the bottom. We don't know how many pounds for the top one. So now we have 7 pounds to make 8 rolls. We need to find how many pounds to make 20 rolls. We have two fractions with an equal sign between, so we can cross multiply. 20 times 7 gets us 140. 8 times x gets us 8x. To isolate our x by itself, we divide by 8. And plugging into our calculator, 140 divided by 8, we get 17.5. Looking for our answer, it's C. Example 2. Rick is on a bicycle trip. Every 4 days he bikes 230 kilometers. If Rick keeps the same pace for 16 days, how many kilometers will he bike? So again, setting up our proportion. He's riding for 4 days and travels 230 kilometers. Now if he goes for 16 days, how many kilometers is he going to go? So setting up my fraction, they tell us 4 days and 230 kilometers. So 230 kilometers per 4 days. We don't know how many kilometers he's going, but we know he's riding for 16 days. Again, cross multiplying. 16 times 230 into our nice calculator is 3,680. And 4 times x gets us 4x. Again, isolating our x, we need to do the opposite of the multiplication. So we're going to divide. 3,680 divided by 4 into our calculator tells us he traveled 920 kilometers.
Question?
Yes, Ellis?
Does days have to be on the bottom?
No, we could actually flip both of our fractions upside down and the problem will still work. Okay, you now have 5 minutes to try your 3 practice problems.
Welcome back. We're on to level 2 now. These problems are a little harder, but not something that we can't handle. Let's take a look at the problem, shall we? During a timed test, Alexander typed 742 words in 14 minutes. Assuming Alexander works at this rate for the next hour, which of the following best approximates the number of words he would type in that hour? Well, first off, I know that Alexander types 742 words in 14 minutes. And I know you're asking to yourself, does minutes have to be on the bottom? And the answer is no. Minutes could be on top. However, because minutes is in the bottom of this fraction, it will need to be in the bottom of our other fraction. This is how proportions work. 742 words in 14 minutes. We want to know if he kept up this rate for the next hour. Now, in my denominator, I have minutes. So, I'm going to have to change this hour into minutes. I think to myself, how many minutes are in an hour? I get that there's 60. Alright, 742 words in 14 minutes. I don't know how many words in 60 minutes, so this is where my variable will go. X words in 60 minutes. From here, we're going to go ahead and use the strategy that we have been using. I have one fraction set equal to another in this proportion, therefore, I can cross multiply. 742 times 60, 14 times x. Remember, whenever you do this, you create an equation, not another fraction. So, I start off with 742 times 60, and I set it equal to 14 times x. Now, I'm going to calculate 742 times 60. I get 44,520. You probably can't see that, but that's okay. On the right side, I still have 14x. Don't be fooled. I know you see that answer. However, our x is not alone yet. We're going to need to isolate x by getting rid of the 14. 14 is being multiplied to x, so we need to divide both sides by 14. Taking my 44,520 and dividing by 14, I get 3,180. That answer is actually C. And I'll see you on the next problem. Welcome back for number 2. Here we have Raheem, and he's trying to calculate the distance of his upcoming road trip from Atlanta, Georgia, that is. Atlanta, Georgia to Nashville, Tennessee. The scale on his map shows that every 1 inch on the map is equal to 300 miles. Every 1 inch on a map is equal to 300 miles in real life. On the map, Raheem measures the distance between Atlanta and Nashville, and he finds it to be 5/6 of an inch. To the nearest 10 miles, how many miles will Raheem have to travel from Atlanta to Nashville during the road trip? Let's set up our proportion. We know that every 1 inch is equal to 300 miles. We want to know the number of miles that Raheem will be traveling. So in this case, I have miles in the denominator. I will have miles in the denominator here. And the number of miles I'm going to travel is what is unknown. So I will put x here. What we do know is that Raheem measured the distance from Atlanta, Georgia to Nashville, Tennessee. And he found out that that was 5/6 of an inch. So in the top of this fraction, we have 5/6 of an inch. Now, not that you need to know this, but this is called a nested fraction. That's when a fraction is inside of a fraction. We still solve it the same way. However, we just need to be careful about how we calculate it. So, we're still going to cross multiply. 1 times x is going to give me x. 300 times 5/6 is 300 times 5/6. This we can plug straight into our calculator. Those who are good at math are already just multiplying 300 times 5 and then dividing that answer by 6. If you aren't as strong with your math skills, that's okay. Let's use the calculator. 300 times 5. Anytime you see a fraction, that means division. So we have 300 times 5 divided by 6. And we find our answer to be 250. X is 250. X was the number of miles away, so we find out that Nashville, Tennessee to Atlanta, Georgia must be 250 miles. You have 6 minutes to complete 2 practice problems from level 2, y'all.
Hi, welcome back to level 3. These are a little bit harder, but stick with it and you'll get it. Alright, so we're going to check out the first level 3 problem here. So Erica plans to purchase seeds or seed to plant grass in a large field. She has a map of the region and calculates the area of the region on paper to be 180 centimeters squared. The scale on the map shows that 1 centimeter equals 20 feet. If you ever look at a map, they got a little scale at the bottom. Erica plans to cover every 400 feet squared with 1 pound of seed. Approximately how many pounds of seed will she need to cover the entire field? Now, the important part here and the difficult part is keeping our units squared away. Our goal is to get to feet squared because feet squared tell us the number of pounds. So we first have to convert our centimeters squared into feet squared. So I'm going to take 180 centimeters squared. Now keep note, centimeters squared is the same as centimeters times centimeters. So I'm going to multiply this fraction by 1 centimeter times another centimeter. This allows me to cancel out my centimeters. Now if we look at our next part, 1 centimeter equals 20 feet. So the numerator will be 20 feet and 20 feet. So when I go to solve this, it ends up being centimeters squared cancels out with these 2 centimeters, leave me with a 1 on the bottom. Feet times feet is feet squared. And then 180 times 20 times 20 is 72,000 feet squared. Now that I have feet squared, I can now use my other conversion, 400 feet squared for 1 pound, to switch the feet squared into pounds. So I'm going to start with my last answer. 7,200 feet squared over 1 times, now in this case, feet squared has to be on the bottom in order to cancel these 2 out. According to my feet squared, it's 400 for every 1 pound. 400, 1 pound. When I multiply these across, feet cancel out, I'm left with 72,000 pounds divided by 400, which will give you 180 pounds. So our answer is D. See you on the next one. Welcome back for our second guided note, level 3 problem. All right, we're going to read through the problem and figure out how to do this proportion ratio. All right, the table at the left, in this case below, lists the average expenditure rates of playing tennis versus playing squash based on a body weight of 55 kilograms. The ratio of each value in the tennis column to the corresponding value in the squash column is about the same throughout the table. I'm just going to highlight that whole sentence right here. That is important. It's telling me that each of these columns are the same ratio from one to the other. Right? Which of the following is the closest to the fat burning rate R of the squash? So, I have to compare these two together, which have the same ratio, according to my highlighted sentence here, as any one of these two. It doesn't matter which 2 you pick, or which other one you pick, as long as you do 77 and 130, or 1,594 and 2,726. It doesn't matter. I'm going to do the smaller numbers because those would be easier to multiply. Still a pain, but easier. So, 49 over 77. So 49 is my fat, 77 is my O2. Equals, we'll have to do the same in the other fraction. R is my fat, and 130 is my O2. At this point, you use your strategy of cross multiplication to help you solve this. So you end up getting 49 times 130 is equal to 77 times R. I'm going to bring this up over here because we're running out of room. So when I multiply these two together, I get 6,370 is equal to 77R. this point, the R is not alone, and it's being multiplied by 77. The opposite of multiplication is division. So I'm going to divide by 77, cancels out, I'm left with an R. What I do to one side, I need to do the other. Divide by 77. The answer approximately ends up being 82.7. Not approximate. Now, in the question, it asks you which one is closest. So if I look through my answers, the closest one to 82.7 is 83, letter C. Good luck. You have about 7 minutes to complete each of the practice problems.